Welcome everyone, and topic is Semantic Tableau System in Propositional Logic. Today, we'll dive into a method used to determine the truth values of propositional formulas and its significance in logic, mathematics, and computer science. Throughout the presentation, we will cover the basics, the step by step process, expansion, rules, practical examples, and applications of the semantic tableau system. The semantic tableau system is a valuable tool in logic and mathematical reasoning. It's used to determine the truth values of the complex propositional formulas and the basics of propositional logic. Propositional logic forms the foundation of our discussion. Proportional variables and the logical connectivities, such as and or not and the truth values, are the key elements. The important lies in its role as the basis for more complex logical systems. Proportional logic deals with the statements. Variables such as p, q, r, and so on represent the statements. Some of the example formulas are P and Q, P or Q, negation P and Q, or negation R, and many more which we already covered in the DM. What exactly is a semantic tableau? Semantic tableau is a systematic method for determining truth values of propositional formulas. It's also known as truth tree or analytic table and is crucial for analyzing the validity and satisfiability of logical expressions. And the purpose of the semantic tableau is it approach the semantic approach for evaluating the truth values of the complex formulas, which means the complex formulas which we seen before can be solved in a systematic approach, a step by step process. And the significance of the systematic tableau is it is the foundation for analyzing the validity and the satisfiability of the logical expression. We will look forward about the validity and satisfiability in the further slides. And mainly systematic tableau is used for the visual representation and a step by step process which guides our evaluation. How does a semantic tableau work? We navigate the semantic tableau process step by step. First step will begin with the formula to evaluate, and continued with applying the rules to expand the tableau. Continue, and we have to continue until the conclusion is reached. Key rules included are end, which we are splitting nodes, or creating branches and not closing the branches. The process is systematic and ensures comprehensive analysis. And the expansion rules are and or and not, which we previously looked through it. And here is an example for it. Now, the satisfiability and the validity. Satisfiability is closing all branches, while validity is keeping all branches open. Significance lies in their role in the logical reasoning. It We can connect to the terminology in our previous examples also. And the advantages of the semantic tableau system is visual clarity and the systematic procedure. The visual clarity means it will highlight the visual representation in understanding the complex formulas, and it emphasizes the systematic approach for the comprehensive analysis. And the limitation involve potential exponential growth in the complexity. It increases the branches, exponentially increases the branches for the complex formulas. And when we look into the real world applications, Some of the real world applications are circuit design, software verification, legal reasoning, medical diagnosis, and business decision making. These examples highlight the practical applications of the semantic tableau. We have covered the key concepts, practical applications, and the real world examples of semantic tableau in propositional logic. Uh, and thank you.